Well, good day. Lecture 4.3 is as part of Module 4 on energy, is going to be focusing on coal and nuclear forms of energy. Although we're predominantly focusing on coal because our case study for this week is on nuclear energy, and our students who are presenting the case study will be presenting information to all of you about nuclear power. So similar to last lecture where we looked at oil and natural gas, in this particular lecture we'll look at the nature and origins of coal. And in conjunction with this lecture and the PowerPoint that your peers are developing, we'll also be looking at the natures and origins of nuclear power. We're going to look at sort of future outlooks for coal and what we anticipate sort of how much coal we have left, how much longer it's going to last, employment outlooks, etc., and then evaluate the political, social, environmental, and economic aspects of continued use or non-continued use of coal. And then you'll do the same thing for nuclear power in your case study and your discussion around that case study. So this slide here is just a reminder of a slide that I had last PowerPoint, and it relates to coal as well, and it actually relates to nuclear power as well. The key advantage of using fossil fuels over, for example, solar power or wind power are these three advantages. It's inexpensive. It has a high energy density, so lots of stored energy. When we burn it, it releases a lot of energy per unit. And we can store the energy from fossil fuels so that we can use it and have it on demand when we need it. All right, so let's look at coal. What is coal? Where does it come from? Coal is similar in that it comes from previously living organisms, similar to natural gas and coal, although it only comes from plants. It does not come from animals. So coal is combustible. It's black or a brownish black sedimentary rock that you've probably at some point in your life held when you studied rocks, maybe back in elementary or high school. It has a very high amount of carbon in it, and it also has a very high amount of hydrocarbons, so hydrogen-carbon bonds. Coal is classified as a non-renewable energy source because it, like natural gas and oil, takes millions of years to form, and it contains all of that energy that was stored in the plants that lived hundreds of millions of years ago. And most of the plants that formed coal were in really swampy, foresty regions at the time that they were living. They then died. They became covered by layers of rocks and dirt, and over millions and millions of years, the pressure and the heat turned the plants into the substance that we call coal. There are 4 types of coal. I bet you never thought when you took this class you'd be learning that there are 4 types of coal. Do not get hung up on the 4 different types of coal. You do not need to memorize these. The biggest thing just is that there's different quality levels in the coal, and they're ranked based on the amount of carbon the coal contains. So the more carbon that's in the coal, the more energy it contains, the more expensive that it's going to be. The amount of carbon in the coal is determined by the amount of pressure and heat that was acted on the plants over time. So usually the higher quality coal is coal that was much further down in the ground. Therefore, it's more expensive to extract and mine and sells for more money. And so the darkest, blackest coal here is the coal that contains the most carbon. It has the highest heating value, but it also accounts for the least amount of coal. There isn't a lot of coal in the world that is of this highest quality. The brown coal that you see on your slide here has the least amount of carbon in it. It is also the coal that's easiest to access. It's on the top of the ground. It's much easier to find and get access to. That is mostly in the United States, found in Texas and North Dakota. The highest, this dark black coal with high amounts of carbon. This is what we're finding in Pennsylvania and West Virginia and those parts of the world. So how do we extract coal? Well, there's two ways to get coal out of the earth. Obviously, they both use very large machines and are very industrial in nature. Many of the United States coal deposits are pretty near the Earth's surface, although some others are pretty deep underground. So as a result, we use two different ways to extract coal. About 2/3 of the coal in the United States is considered to be a surface coal mining operation, which then the other third requires coal miners to dig deep down into the ground. So surface mining is usually used when the coal is less than 200 feet underground. In surface mining, large machines just remove all the topsoil and the layers of dirt in order to expose the coal, and then that coal is mined. Mountaintop removal might be something that you've heard of before. It's a form of surface mining where the tops of mountains are actually dynamited off and removed, and that way you can access coal seams. Once the coal is removed in a surface mining operation, the land area is usually covered with topsoil and planted with grass and trees. And this obviously is less expensive than deep mining. And so it's the more common form of mining in the United States. Underground mining, sometimes called deep mining, happens anytime the coal is several hundred feet below the surface. Some coal mines that are underground are like 1,000 feet deep and go for miles and miles. And they ride elevators down deep mine shafts, and they travel on these small little trains and go in tunnels. And it makes me claustrophobic, and my anxiety increases just thinking about going down those elevators and riding in those little tunnels. And then they use machines underground to dig out the coal, which you can imagine can be quite dangerous if safety regulations aren't being followed. So that's the two ways to get coal out of the earth. What do we use coal for? Here in the United States, 30% of our electricity comes from coal, but 91% of all coal that's mined in the United States is used for electricity. So even though we're only getting about 1/3 of our electricity from coal, almost all the coal that we mine and extract is used for that. Power plants make steam to turn their turbines by burning the coal, and that's how we generate electricity. Globally, about 41% of our electricity comes from coal, so not quite half, but it's still very important on a global scale in terms of generating global electricity needs. There's then, of course, the remaining about 9% of coal, and what do we do with that? Well, about 8% of it, is used in industry. There's coal and coal byproducts. It can be used in the concrete industry. Paper industries use coal. The steel industry, actually, though, is what uses a lot of this 8% indirectly. You can create, through several chemical reactions and processes, you can create steel through coal. And then 1% of it is used commercially, very small amounts of it. You can actually turn coal into a liquid, which then gets used for various different things as well. But mostly what we use coal for is to make electricity. And so, if we find other ways to make electricity and generate electricity, we do not need as much coal. Are we running out of coal? Well, no, we're not. Coal is still very readily available in many places around the world, and it's been for a while the fastest growing global energy source. And while we're seeing some provisional data that maybe shows that we're starting to see a slight decrease in coal production, um, it's still very strong. It's still increasing globally, we think. Um, and we're not seeing a drastic decline in reserves of coal. We are, however, seeing a decline in demand for coal, um, particularly in the developing world, as we focus more on renewable energy resources and as natural gas has become more prominent in terms of energy production. We have seen a decline for coal in the developed world. Um, and this is just as we see greater governmental policy support for renewable energy and energy efficiency. The Paris Agreement, all of these things are putting a dent in the demand for coal. Um, but in places like India and China and Southeast Asia, we're still seeing increased demand there, which is kind of offsetting the decline for coal in the United States and Europe. Um, so, nevertheless, we're not running out of coal. We have a lot of coal left, at least for several more decades, probably through the end of at least this century. And we don't see, or a couple of centuries, and we don't really see peak coal production happening for another couple of decades either. Coal in the United States has been an integral part of our industrial development. It's what has helped us be economically developed. We have a lot of coal in the United States. Our coal reserves are vast, and our mining technology is well developed, and it has spread through many parts of the country. So we've been able to support many different local economies. So the coal industry is important to the economics of the United States, very important. In the year 2015, we were making about 897 billion tons of coal were being produced. About 66% of that was coming from surface mines. And you can see on this particular figure here, the top 5 producing coal states in the United States are Pennsylvania, West Virginia, Kentucky, Illinois, and Wyoming. Although there are coal mines in a lot of other states as well. But those 5 states account for approximately 71% of all coal production. This is important particularly because politically, these states then become very important during election cycles based off of what politicians have as priorities and what they're promising coal miners and coal executives and things like that. The Appalachian coal region, which is Kentucky, Pennsylvania, West Virginia, but also somewhat Virginia, Tennessee, Ohio. About a quarter of all the coal in the United States is coming from the Appalachian region, which of all of those, West Virginia is the largest coal producing state. And underground mines are where most of the coal is coming from in that region. So even though surface mines dominate the United States coal production as a whole, in the Appalachian region, we have a lot of underground mines happening. Unfortunately, from an economic and from an employment perspective, the United States coal industry is declining. We are seeing We are seeing coal-fired electricity generating plants close, um, and they're closing more rapidly than any other time in history. And we're also seeing, and we have seen over the last several decades, a drastic decline in people who are employed through the coal mining industry. Um, I put a figure up here that you can see. I think this is an interesting figure because recent news is making it seem like we have seen this decline only since the start of the Obama administration. But if you look at the statistics going back into the 90s and into the 80s and even before then, you can see that we've had a drastic decline in coal mining employment well before Obama came into administration. So there's a number of things that are causing this. Um, I think first and foremost is natural gas. It's becoming lower cost to use natural gas. Natural gas is increasing in demand. We are also seeing an increase in renewable energy sources, and we are seeing an increase in regulations and standards on coal fired generating facilities that are there to design and protect public human health or ecosystem health, um, which some people are saying is causing these coal-fired generators to shut down or go bankrupt. We're also seeing decades of mechanization and technology development, which means that fewer people are needed to do the jobs that they used to do. And so all of these things have really spurred a wave of coal companies that have declared bankruptcy over the last several decades. And these woes are really honestly just directly related to a drop in demand for coal. They're in the United States, we are not using as much coal as we used to use. And so, although a lot of the coal industry executives and many Republicans for that matter would like the US public to believe that it's these Obama era regulations that went out of control, that were placed on the coal industry, that though that's what's caused a decline in employment and production, it's really the case that we have seen this decline for several decades, and um, it's it's not just the regulations. And sure, the regulations have played a part in it, but we also have cleaner air because of the regulations. So, um, but as I've already said, we've seen a boom in natural gas. It costs less now to use the wind and the sun to generate electricity, and so we have cheap natural gas, we have cheaper wind energy, we have cheaper solar energy, and people are making the switch. People are recognizing that it is better to produce electricity through cleaner sources of electricity production, and they're switching. Um, and and as a result, it's, like, for example, it's like 50%, it costs 50% less to use wind energy to produce electricity now than it did 10 years ago. So as we're seeing the cost of wind power drop, a lot of it's getting to the point where wind and solar energy is becoming cost competitive with fossil fuel technologies. And so obviously, um, power companies are paying attention and are switching. And so they're using less coal, they're demanding less coal, and that is also contributing to the decline. We are seeing an increase in jobs in the renewable energy industry. We're seeing more people being employed by wind and solar energy, while we're seeing coal-generated employment, coal-related employment decrease. Uh, so there's always two sides to every coin, and it's a very complicated issue. I think, though, one thing that we do have to remember in all of this discussion is that there are real people who are unemployed and real people who are suffering because of the decline of the coal industry in the United States. And there are lots of debates out there about what we should be doing in areas like the Appalachians to um, bring economic development and bring employment. And I don't know that we have a good solution yet, but I have a short video here that I would like you to pause the slide presentation for and watch. This is video was made before the election, um, talking to people in the Appalachian region why they were voting for Trump. And I think it's really insightful to remember, as a way to remember that these are real people that we're talking about when we talk about these issues. So just go ahead and pause and watch that, and then come back to the presentation. All right, so if you were paying attention, and hopefully you were, and if you're still paying attention to what's happening politically in our country, one of the things that was really obvious was that Trump campaigned on promises to reinvigorate the coal industry in the United States. He frequently and repeatedly said that he was going to get rid of Barack Obama's Clean Power Plan. So, if you don't know what that is, it was sort of a signature piece of regulation of Obama's. Um, it was related specifically to his goals for climate change. So, the Clean Power Plan was designed to cut the power industry in the United States carbon emissions by 32% by the year 2030. That obviously requires us to move more in the direction of renewable energy production and less in the direction of coal energy production. And the Clean Power Plan was one of Obama's pieces of regulation, and it was something that Trump campaigned on over and over again that he was going to eliminate. Is working on eliminating now. Coal executives blame the Clean Power Plan as one of the main reasons why coal-fired power plants have been shutting down and why they haven't been building new coal-fired power plants. And so coal executives obviously do not like the Clean Power Plan. It's also what a lot of workers who are employed as coal miners use to argue that the reasons why they've lost their jobs. So, um, you know, hopefully, as we talk about these issues this week related to energy, you can start to see how intertwined government policy is with all of these things, and how the government has so much influence and power over energy production and energy policy within a country. So the PowerPoint slide that I have up front of you is just to show you, these are just headlines from the last 4 weeks that I've just pulled off of the internet. And there is both the Democrats and the Republicans are telling a story. The Republicans are telling the story that Trump is bringing all of these coal mining jobs back to the United States. The Democrats are saying that that's false, that it's misleading, that the statistics and the data doesn't add up. The coal mining executives themselves actually have gone on the record and saying, you know, it's unrealistic to think that we're going to get all of these jobs back, because it's not just about regulations. It's about the fact that the demand for coal is not there. So I think that over the next 4 years, 3.5 years at this point, we are going to continue to see a lot of discussion around coal, the coal industry, and coal and policies and the roles that the government can play in all of that. All right, so then finally, I just want to talk a little bit about how this all relates back to sustainability. So a couple of things, we've talked about them already. Coal is readily available in the world. So unlike oil, there aren't a lot of geopolitical risks associated with coal. Um, we do not have to rely on other countries and the goodwill of those countries to sell us coal because we have coal in our own country. And that's the case around the world. Most countries have allies that they are fairly stable with over the long term, that they know they are going to get coal from if they cannot produce it in their own country. So geopolitically, coal does not become part of the conversation globally. Obviously, in the United States, politically, coal is a huge hot topic. Um, Coal obviously has all sorts of implications on an economic sustainability standpoint. Our economy, our GDP, all of that is dependent to a degree on coal production. And then there are real people living in these areas of coal mines that's their main source of income, that's their job, that's what they know how to do. And if those jobs go away, they do not have backup plans. So we have strong economic implications. What I think, though, we really have to come to terms with is that the environmental risks of coal are um, are great, and that is why so many people are saying we should not be trying to revive the coal industry. We should be finding alternative, renewable sources of energy and making employment for those people through renewable energy. So coal mining itself is actually very hard on the environment, surface mines and underground mines. Um, they obviously remove topsoil and rock. Um, they disturb the actual surface of the earth and the ground. They can the use of explosives and blowing up the tops of mountains. Obviously, you are disturbing ecosystems and habitats for animals. You're just changing landscapes. You are sometimes, blowing rock and debris into rivers and streams and filling them. Um, there's also a lot of concern that the water that drains from coal mine regions is polluted and can have really harmful chemicals in them. Um, Although there are US laws that require any dust and water that's running off from these areas be controlled and reclaimed and cleaned, there are still controversies over whether or not that is happening adequately. Underground mines generally have a lesser effect on the landscape compared to surface mines. Um, However, there's obviously significant safety risks, and people have died in underground mines, so there's that aspect to them. Um, Coal beds often also are traps for methane gas, and if it becomes really concentrated in an underground mine, it can cause explosions. And so underground coal mines always need to have venting out of them so that the methane can be safe to work in. Um, when we are venting that methane out of the coal mine, we are venting it into our atmosphere. Methane is a greenhouse gas, remember? And so we are emitting a greenhouse gas into the atmosphere. We're removing it from the earth and emitting it into the atmosphere. Some mines actually capture that methane instead of just emitting it, and then they'll use it for other purposes, but not all do. But more concerning than the mines themselves probably is what happens when we burn coal. So when we burn coal to make electricity, we know now that we are emitting a lot of carbon dioxide, the primary greenhouse gas. But coal itself is also just dirty in other ways. It emits sulfur dioxide, which is one of the major causes of acid rain. It emits nitrogen oxides, which is one of the major causes of smog, and other particulates which can make things cause respiratory illnesses, lung disease, etc. So when we burn coal, it's dirty. Oh, it also releases mercury and cadmium and other heavy metals, which have been linked to cancers and neurological issues in humans and animals. So, from a sustainability perspective, the danger isn't really that we're going to run out of coal or that we won't be able to access coal. It's the fact that coal is dirty. Coal puts pollution into our atmosphere. Coal contributes to climate change, and we really can't cope with that and be seriously considering ourselves to be sustainable in the next 100 years. All right, so then I just have 2 slides for you on nuclear energy. Nuclear energy through fission can release 1,000,000 times more energy, and I'm not just exaggerating that, literally 1,000,000 times more energy per atom than fossil fuels. So it contains a huge amount of energy, um, which can then be integrated into our electricity grids and um, it uses the same infrastructure as fossil fuel electricity does, and so it can be seamlessly integrated into our electricity system that we already have. Nuclear has large power generating capacity and it actually has very low operating costs, so its return on investment is huge once it's up and operating. Upfront costs for building a nuclear power plant are intense. They're huge. They present huge financial risks. It takes decades to build a nuclear power plant. And so you're kind of carrying all of that investment before you start getting a return. And so it's very expensive. About 11% of all electricity in the world is generated through nuclear power. And then here I just have a map to show you where there are currently nuclear power plants in the United States. You can see we have one in southeastern Kansas and a few in southeastern Nebraska as well. There are over 440 nuclear power reactors throughout the world, and about 60 or more are being built right now. And as I already said, they make up about 11% of all of our electricity. The biggest environmental benefit of a nuclear power reactor is that it doesn't emit any carbon dioxide emissions. So it's considered in that sense, in terms of greenhouse gases, it's a clean way of generating electricity. So you can see that France globally produces more nuclear energy than any other country, and the United States is kind of in the middle here of the countries that are listed here. Obviously, it's much more common to generate nuclear power in a more developed country than in a lesser developed country because of the cost investments up front. So that's all I'm going to say about nuclear power production. I would like you guys to, if you haven't already, view the case study PowerPoint presentation that your peers have developed. And they are going to, in that, go over nuclear power production in more details and give you pros and cons. And then there is a group discussion forum that you guys need to log into this week related to the case study and engage in there as well. So there are 2 group discussion forums this week that you need to be engaging in. Your regular one with the questions that I posed in your small group, and then there is the case study discussion as well.